What if everything humanity has ever known, the glow of the stars, the pull of the earth beneath our feet, the very warmth of a touch, is nothing more than a projection? A shadow painted across the surface of reality, like images on a cosmic screen. For thousands of years, people have gazed into the heavens, believing the stars to be eternal lanterns guiding them through the darkness. Yet behind that brilliance may lie something stranger, a universe not built from matter and space, but from patterns of information etched upon a boundary we cannot see. The ancients once spoke of shadows on a cave wall, prisoners mistaking illusions for truth. Could we, too, be bound within a grander cave, staring at the flickering images of galaxies, blind to the deeper reality from which they spring? Universe itself is a hologram, then our lives, our histories. Even time's relentless march may be woven not from substance, but from codes of light and geometry hidden at the edge of the cosmos. It is a question that unsettles the foundations of existence. If everything we hold as real is but a projection, what does real mean at all? This is not poetry alone, nor philosophy only. It is a possibility born from physics itself, carried on the paradoxes of black holes and the mathematics of space-time. And so the mystery begins, a journey into the strange. Luminous truth that our three-dimensional universe may be no more than an image, shimmering upon the surface of a deeper unseen reality. The story of science is often told as a march toward clarity, a steady unveiling of the hidden order of the cosmos. But in truth, its path is jagged, marked not only by discovery but by rupture. There are moments when the universe seems to contradict itself, when the laws we thought were eternal collapse under the weight of paradox. And in the late 20th century, such a paradox appeared at the heart of physics. It was not a minor flaw, nor a subtle crack. It was a fracture that threatened to tear the entire foundation apart. At the center of this upheaval stood the black hole, the strangest of Einstein's children. General relativity had predicted them as prisons of gravity, regions where space and time folded so steeply that nothing, not even light, could escape. For decades, they were thought to be cosmic dead ends, eternal, silent, unchanging. But then came Stephen Hawking, and with him, the revelation that black holes were not so silent after all. In the early 1970s, Hawking combined Einstein's curved space-time with the strange rules of quantum mechanics, and what emerged was astonishing. Black holes, he argued, should not be perfectly black. At their horizons, the quantum vacuum itself should shimmer, producing a faint stream of radiation. This whisper of energy, now known as Hawking radiation, would bleed a black hole of its mass over unimaginable stretches of time, until at last it would evaporate into nothing. It was a breathtaking insight, one that joined two great pillars of modern physics, relativity and quantum theory, into a single picture. Yet hidden within it was a devastating contradiction. Quantum mechanics insists upon a sacred law. Information cannot be destroyed. The precise arrangement of every particle, every quantum state, must always be preserved, no matter how violently. Matter is transformed. Shattered teacup, reduced to dust, still retains its quantum information. Even in fire, in fusion, in chaos, the details are never lost. But Hawking's radiation seemed to tell a different story. If a black hole truly evaporates away into featureless thermal radiation, then all the information of what fell inside the stars, or the gas, perhaps even civilizations, would vanish. Without a trace, this was more than unsettling. It was a direct violation of the most fundamental law of quantum theory. Two visions of reality now stood at war. On one side, Einstein's relativity, smooth, deterministic, curved space-time, in which black holes obeyed the iron rule of geometry. On the other, the quantum world, probabilistic, jittering, but unwavering in its insistence that information is eternal. If Hawking was right, then quantum mechanics was broken. If quantum mechanics was right, then relativity had deceived us. It seemed the universe could not hold both truths together. Physicists across the world felt the tremor. For decades, they had balanced the uneasy marriage of relativity and quantum theory, the grand equations of the cosmos, and the fine-grained laws of the subatomic world. Both had worked flawlessly in their own domains. But now, at the event horizon of a black hole, the two refused to coexist. Reality itself seemed inconsistent. The implications were terrifying. If the laws of physics contradicted each other, then perhaps they were not laws at all. Perhaps the universe was built on a logic that humans had not yet glimpsed. Something deeper, stranger, hidden beneath the veil. And in that fear, some began to whisper an idea as radical as it was unsettling. Maybe our three-dimensional universe was not fundamental. Maybe it was encoded, as if written on a boundary, projected inward like a cosmic hologram. The seeds of this thought had been planted in earlier insights. In 1972, Jacob Bekenstein had noticed something extraordinary. The entropy, the measure of disorder or information inside a black hole, seemed to scale not with its volume, but with its surface area. It was as though the horizon, a two-dimensional shell, somehow stored the full information of a three-dimensional interior. Hawking himself was skeptical, yet his radiation discovery soon vindicated Bekenstein's strange intuition. The message was unsettlingly clear. The fabric of reality might not be what it seems. The true content of the universe could be written not in volumes, but on surfaces, as though existence itself were a projection. This was the scientific shock the moment physics broke itself. The elegance of Einstein collided with the absolutes of quantum law, and in the wreckage, a radical vision began to emerge. The cosmos might not be what our senses insist. Its depth, its solidity, its very space could be nothing more than an illusion born from a hidden code at its edges. For the physicists of the time, it was both terrifying and electrifying. To accept the holographic principle was to admit that the universe was not built of matter alone, nor even of energy, but of information. And information does not vanish. Information endures. Still, in those first years, the idea was treated with suspicion, even disdain. It sounded absurd, the language of philosophy, not science. How could the infinite richness of a galaxy, the motion of planets, the birth and death of stars, all be nothing more than data pressed upon a cosmic screen? The notion lingered at the fringes, whispered in the hallways of universities, scribbled in the margins of papers. But as the paradox deepened, resistance began to wane. The crisis could not be ignored. Hawking himself doubled down, declaring with confidence that information truly was lost in black holes. It was a bold stance, one that placed him against the central creed of quantum theory. The debates grew heated, sometimes bitter. Conferences erupted in arguments that spilled late into the night. Physics, it seemed, had reached a breaking point. Yet from this fracture came a new generation of ideas. If relativity and quantum mechanics could not both be correct at the horizon of a black hole, then perhaps they were not final at all. Perhaps both were approximations of a still deeper law, one in which space and time themselves were not primary. In that vision, the universe would be like a hologram, an image arising from a hidden surface of information. Just as a two-dimensional holographic plate produces the illusion of three-dimensional depth, it was a staggering thought. The stars above, the galaxies swirling across the void, the very sense of here and now, all might be projections, shimmering from the edges of a deeper, invisible truth. And though the idea would take decades to mature, its roots were here in the paradox of black holes. In the shock of physics colliding with itself, for the first time, humanity was forced to confront a possibility it had never imagined, that the cosmos was not as real as it seemed. That reality itself might be an illusion, a grand shimmering hologram, whose true form lies hidden beyond the horizon. At the edge of a black hole, there exists a silence so complete it defies imagination. This is the event horizon, a place where the familiar rules of nature dissolve into strangeness. To cross it is to step into an abyss where time itself bends and falls inward, never to return. For decades, scientists believed this horizon was nothing more than a one-way gate, the edge of a cosmic abyss from which no signal could escape. But slowly, a more unsettling possibility emerged. Perhaps the horizon was not simply a boundary. Perhaps it was something far stranger, a surface that contained the very essence of the world within. In the 1970s, Jacob Bekenstein studied the thermodynamics of black holes and found something astonishing. When matter falls into a black hole, it vanishes from view. Yet somehow the entropy, the measure of disorder, the tally of microscopic arrangements does not vanish. Instead, it seems to increase in a precise way. But it did not increase in proportion to the black hole's volume as one might expect. Instead, it scaled with the surface area of its horizon. Mathematics was unrelenting. The black hole's information capacity was two-dimensional, not three. It was a revelation that challenged common sense. Imagine a vast library, not measured by the space of its shelves, but only by the paint that coats its outer walls. Picture an ocean of depth and motion, its entire content somehow stored upon the surface of its waves. The black holes seem to whisper that nature did not keep its records in volume but on surfaces' delicate skins, stretched across the fabric of reality. This insight carried the haunting echo of something familiar, a hologram. A hologram begins as a flat plate, etched with interference patterns of light. Yet when illuminated, it blooms into the illusion of three-dimensional form. A flat surface generates a world of depth. And here, at the edge of a black hole, the same principles seem to emerge. The horizon was not simply a curtain. It might be the place where the universe itself keeps its deepest secrets. It's written as if on a cosmic holographic plate. Stephen Hawking's later discovery of black hole evaporation sharpened the paradox. If information truly clung to the horizon, then perhaps it was not lost after all. Perhaps the black hole radiated not ignorance, but whispers of its hidden archive. In the strange glow of Hawking radiation, some suspected that the information of all that had fallen inside was encrypted, stretched thin across the surface, like a story told in another tongue. To decode it would be to glimpse how the universe itself remembers. This radical picture shook the very foundation of physics. It suggested that reality as we perceive it, the solidity of three dimensions, may be a grand projection from a deeper truth. Inscribed upon two-dimensional boundaries, the walls of space-time, not its volume, might hold the code. For years, the idea remained more poetry than proof. It was a metaphor that tantalized, but lacked the rigorous language of mathematics. Then, in 1997, a young Argentine physicist named Juan Maldacena found a bridge. Working in the landscape of string theory, he proposed something bold, that a universe described by gravity in a higher dimensional space could be fully equivalent to a universe without gravity, existing on its boundary. This was the ADS-CFT correspondence, anti-de Sitter space, and conformal field theory, woven together in a duality of unimaginable depth. The claim was audacious, two utterly different descriptions of reality. One with gravity, one without, were in fact identical. One was written in the language of space-time and curvature. The other was written in the language of fields and quantum interactions, confined to a lower dimension. The bulk and its boundary were mirrors, each containing the other's truth. A cosmos within and a cosmos without, singing the same equations in different forms. Physicists around the world felt the tremor. For the first time, the holographic principle was not just metaphor. It had mathematics behind it, precise and testable. Maldacena's correspondence was hailed as a breakthrough, offering the strongest evidence yet that the holographic vision of the universe might be real. In seminars and papers, physicists spoke of holography not as a dream, but as a framework, a new lens through which to glimpse the unity of physics. It was as if a doorway had opened. Behind it lay the possibility that everything, stars, galaxies, perhaps even the passage of time, might be the projection of a deeper, lower dimensional reality inscribed upon a distant boundary. In this view, our world of volume and depth is an emergent illusion, much like the shimmering depth of a holographic image. The true description of the universe may lie elsewhere, hidden, invisible, yet inexorably shaping the reality we experience. This realization carried profound weight. If space and time themselves emerge from information written upon boundaries, then the fabric of reality is not substance, but code. The atoms that compose mountains, oceans, and human lives may be nothing more than arrangements of data woven into a tapestry at the edge of existence. Matter, motion, and memory could all be emergent shadows cast by a deeper geometry. And yet, as profound as this was, it was also deeply unsettling. For if reality is holographic, then the solidity of the world is an illusion. What we touch, what we measure, what we believe to be permanent, is but a projection of something we cannot see. Humanity, gazing into the night sky, might be like those prisoners in Plato's cave, staring at flickering shadows while the true fire burns far beyond their reach. Still, the idea gave hope. For if the universe is holographic, then the paradox of black holes may not be a catastrophe. Information is not lost, but stored in a deeper, more subtle way. Quantum mechanics and relativity, once at war, might be reconciled within this framework. The rift in physics could become a bridge, yet mysteries remain. Maldacina's duality is not the universe we inhabit, but a carefully chosen cousin, a toy. Model with negative curvature, unlike our own expanding cosmos. Whether holography extends to the real universe is still an open question. But even as a model, it revealed something profound. Reality can be encoded in ways more subtle and beautiful than anyone had imagined. The event horizon, once seen as a place of endings, has become instead a place of beginnings. It is here, on this strange and silent surface, that physics first glimpsed the possibility that depth is illusion, that the universe is a projection, and that all we know may be written upon the edges of existence itself. In peering into the horizon, humanity did not just study black holes. It caught a reflection of its own reality, fragile, luminous, and perhaps not as real as it seems. If the universe is a projection, then its secrets are not hidden in myths or metaphors alone. They should be inscribed in the patterns of nature, etched across the oldest light, murmured in the trembling fabric of space-time itself, to uncover such whispers. Humanity has turned its most powerful eyes and instruments toward the cosmos, stretching the reach of its machines to the very edge of what can be measured. In these traces of data, some believe may lie the first hints that reality is not what it seems. The journey begins with light older than stars. Nearly 14 billion years ago, the newborn universe erupted in a flash of brilliance, the afterglow of the Big Bang, still streaming across the cosmos today as the cosmic microwave background. This faint radiation cooled now to just above absolute zero is the oldest portrait of the universe, a frozen echo of its infancy. When the European Space Agency's Planck satellite launched in 2009, its mission was to capture that portrait in unprecedented detail. For 4 years it traced the microwave sky, mapping tiny fluctuations in temperature and polarization with exquisite precision. What it revealed was both breathtaking and unsettling. The cosmic background was not perfectly uniform. It shimmered, with faint irregularities, spots slightly warmer, patches slightly cooler, primordial ripples that seeded the galaxies we see today. Yet within this ancient light, researchers also found anomalies. One anomaly became known as the axis of evil, peculiar alignment of temperature fluctuations stretching across the sky, defying the randomness expected from inflationary theory. Others noted asymmetries, cold spots larger than theory allowed, and curious patterns that refused to dissolve under statistical scrutiny. To some, these were simply accidents of chance, quirks of cosmic variance, but to others, they carried a whisper. Perhaps the anomalies were not random at all, but faint fingerprints of a deeper structure, the holographic encoding of the universe itself. The speculation was audacious. If the universe is a hologram, then its projection might leave subtle traces in the cosmic microwave background. Tiny deviations in geometry, delicate correlations in the noise. In the grain of ancient light, one might glimpse the edge of the cosmic screen. Beyond the light of the past, physicists also searched the quantum present. At Fermilab, near Chicago, a peculiar machine was built for an equally peculiar question. It was called the holometer, a pair of high-powered interferometers designed to probe reality itself for signs of holographic noise. The principle was simple in design, though staggering in implication. If space-time is not continuous but discrete, woven from bits of information at the Planck scale, then its fluctuations might jitter like pixels on a screen. That jitter, impossibly small yet omnipresent, could create a faint background noise, a blur in the very coordinates of reality. The holometer set out to measure that blur. Using laser beams, split and recombined along arms 40 meters long, the instrument sought to detect correlations in noise that could not be explained by classical physics. If such noise appeared, it would be the first evidence that space-time is holographic, projection built from fundamental units of information. For years, the holometer listened to the silence, sifting through vibrations, filtering out the hum of machines, the tremors of Earth, the faint whispers of cosmic rays. The results, when they came, were inconclusive. No definitive holographic noise was found. That even in failure, the experiment marked a turning point. It showed that the question of holography was no longer confined to the blackboards of theorists. It had entered the realm of experiment, of machines built to test the fabric of existence itself. And still, the difficulty remains immense. For how does one test a projection from within the projection? If the universe is holographic, then every instrument, every particle, every observer is already part of the illusion. To search for the code of reality is like a dream trying to measure the bed in which it is dreamt. The challenge is not just technological, but philosophical. How to distinguish the signal of the real from the pattern of the illusion? Yet scientists press on, their methods ever more refined. The cosmic microwave background continues to be probed, not only by Planck, but by successors searching for the faint imprint of primordial gravitational waves. Particle accelerators push the boundaries of energy, smashing protons together to peel back the layers of quantum reality. Quantum computers begin to simulate holographic models, testing whether emergent spacetime can arise from entangled qubits. Each effort is a fragment of a larger quest to determine whether the universe we inhabit is fundamental or merely emergent, to ask whether space and time are fabric or projection, to search for signs that the vastness of the cosmos is a hologram. It's written at the edges of reality and cast inward into the depths of our experience. The data so far is elusive. The anomalies in the cosmic background remain unresolved, straddling the boundary between coincidence and significance. The holometer, silent in its search, leaves open questions for new generations of instruments. The mathematics of holography continues to deepen, revealing correspondences and dualities, but no definitive proof. And yet, in this uncertainty lies a profound truth. For the act of searching is itself a testament to the human spirit, a refusal to accept appearances, a hunger to see what lies beneath the surface. Whether or not the universe is holographic, the quest reshapes our vision of reality, forces us to confront the possibility that what we call real may be no more than a shadow, a coded image, a flickering light upon the cave wall of existence, in the patterns of ancient radiation, in the silence of interferometers. In the equations of theoretical physicists, humanity peers into the edge of the horizon, searching for the faint handwriting of the cosmos. And perhaps one day, hidden in the noise, a message will emerge that the universe is not what it seems, that its depth is illusion, and that beyond the veil lies a truth both stranger and more magnificent than anyone has yet imagined. The deeper physics peered into the question of holography, the more unsettling the picture became. What began as a puzzle at the edge of black holes soon expanded into a possibility that touched everything: the stars above, the ground beneath, the very notion of existence itself. If the holographic principle is true, then reality is not fundamental. It is emergent. What we call matter, energy, even the flow of time, may be nothing more than illusions, conjured from the hidden language of information inscribed on a cosmic screen. This is the escalation of the mystery, for it means the universe is not built from the things we see, but from the codes that describe them. The solidity of a mountain, the fire of a star, the curve of a galaxy are not ultimate realities, but shadows of information arranged across surfaces we cannot reach. To live in such a world is to inhabit a projection. To exist is to be part of a pattern woven from unseen data. Gravity, once thought the most fundamental of forces, stands at the center of this transformation. Einstein revealed it not as a pull, but as the curvature of space-time itself. Yet holography suggests something even more radical. Perhaps gravity is not fundamental at all. Perhaps it is emergent, an effect born from the thermodynamics of information encoded at boundaries. Eric Verland, a Dutch theoretical physicist, has argued that gravity may arise the way heat arises from the motion of molecules, not as a basic law, but as a statistical outcome of hidden microscopic data. In this vision, the fall of an apple, the orbit of a planet, the binding of galaxies are all echoes of an invisible code, a bookkeeping of information written on cosmic surfaces. If so, then the most majestic structures in the universe are born not from substance, but from the rules of information flow. Space itself may stretch and curve because the hidden ledger of data demands it. Time may flow because the unfolding of information requires it. The cosmos, in its grandeur, could be nothing more than the shadow of a deeper, unseen computation. The implications extend further into the most intimate realm of all, consciousness. If reality itself is emergent, then the mind may be as well. What we call thought, memory, and awareness may not be fundamental sparks of existence, but holographic phenomena, illusions born from information encoded at boundaries beyond perception. Some scientists speculate that entanglement, the quantum thread that weaves particles into correlations across vast distances, could also weave the fabric of experience, that the sense of self, the feeling of being alive, is bound to the same codes that project galaxies into existence. It is a haunting idea. For if consciousness is holographic, then the boundary does not only hold the history of stars and black holes, it holds the history of minds, every dream, every perception, every flicker of thought stored not within the brain alone, but as patterns stretched across the holographic canvas of reality. To exist in this view is to be etched into the universe itself, not in substance, but in information. This escalation transforms the mystery from physics into philosophy. If everything is emergent, then what is fundamental? If space and time are illusions, what lies beneath them? The holographic principle does not yet provide answers, only questions. It whispers that the reality we cling to is a shadow, but leaves us in darkness about the source of the light. The challenge is profound. To imagine reality as emergent is to abandon the comforts of solidity. No longer is the universe a stage of matter, moving through space, governed by time. Instead, all of it is patterns of information, projected, decoded, and experienced as a world of depth and form. The ground beneath us, the stars above, is the rhythm of our own heartbeat. All of it may be no more than the shimmering illusion of a cosmic hologram. And yet, within the unease lies a strange beauty. For if the universe is holographic, then every particle, every life, every thought is part of the grand code woven into the very surface of existence. Nothing is ever lost. Information once written endures. The story of the cosmos is not erased, but preserved, stretched across boundaries that outlast stars and galaxies. In such a vision, the fragility of existence is transformed into permanence, not of matter, but of meaning. Still, the escalation does not end there, for if reality is emergent, then perhaps it can change. If gravity, space, and time are not ultimate, then they are not unbreakable. The rules of the projection may be altered, the codes rewritten. What appears as a mutable law may in fact be contingent, a feature of this hologram, but not of all possible holograms. It raises the specter of other universes, other projections, encoded by other rules. It raises the haunting question of whether our own projection could one day end. Could the hologram flicker, distort, collapse into nothing? Could the code itself shift, erasing space and time in ways we cannot comprehend? The possibility is terrifying, for it suggests the fragility not only of galaxies but of existence itself. If reality is emergent, then reality can fail, and so the mystery deepens, escalating into regions where physics blends with metaphysics, where science touches philosophy, and where the boundaries of imagination strain against the limits of reason. The holographic principle began as a solution to a paradox, a way to preserve the sanctity of information in black holes. But it has grown into something larger, something that questions the nature of everything. It is no longer about horizons alone, but about the universe itself, and about the minds that wander within it, at its heart. The escalation brings humanity to a place both fragile and profound. Fragile, because the solidity of existence is revealed as illusion. Profound, because illusion or not, the patterns are real enough to dream, to live, to wonder. Whether projection or substance, the universe remains a place of beauty, a mystery that deepens the more it is understood. In the rising tide of this realization, one truth becomes clear. If the universe is a hologram, then to exist is to be part of a story written not in matter, but in information. A story that stretches from the birth of stars to the birth of minds, from the silence of black holes to the murmur of human thought. A story that may never end, because in the language of information, nothing is ever truly lost. Asterisk. As the horizon of physics cracked open under the weight of paradox, the holographic principle began to emerge not merely as a daring metaphor, but as a bridge, a fragile, luminous span between two towering mountains that had long stood opposed. On one side loomed the smooth, majestic architecture of Einstein's relativity, where space curved and time flowed with elegant inevitability. On the other stood the restless, granular, jittering world of quantum mechanics, where chance ruled, and particles flickered in and out of being. For nearly a century, these realms had refused to reconcile, speaking different languages, obeying different laws. Yet the holographic idea offered a strange and profound possibility. Perhaps both visions were shadows cast by a deeper and unified reality, written not in substance, but in information. Here, in the shimmering tension between the vast and the minute, between continuity and probability, physicists began to glimpse a new way forward. The holographic principle could be the reconciliation, not by erasing one theory in favor of the other, but by revealing both as projections of a deeper truth. String theory, the great unfinished symphony of modern physics, became the stage where these ideas first found form. In its mathematics, the universe is not built from point-like particles, but from tiny vibrating strings of energy, each mode of vibration giving rise to the particles and forces of nature. For decades, string theory promised unification, yet it carried with it an unsettling abundance, extra dimensions beyond the three of space and one of time, hidden from perception, curled into shapes too small to see. For many, these dimensions seemed extravagant, untestable, but through the lens of holography, they gained a new meaning: the ADS-CFT correspondence, proposed by Juan Maldacena in 1997, revealed that a universe with gravity in a higher dimensional space could be exactly equivalent to a quantum field theory defined on its lower dimensional boundary. The extra dimensions, once regarded with suspicion, were not decorations at all, but the depth of the holographic image. Just as the shimmering 3D illusion of a hologram arises from the encoding on a 2D plate, the higher dimensional bulk of spacetime could arise from quantum interactions woven across a lower dimensional frontier. In this vision, the familiar universe becomes emergent, conjured from mathematics written elsewhere. The dimensions we move through, the curvature that guides galaxies, the very fabric of spacetime itself, are shadows projected from a deeper informational structure. The two great pillars, relativity's smooth spacetime and quantum theories. Granular uncertainty may both be encodings of the same underlying holographic truth, but what weaves the hologram together? What stitches space into coherence? What binds time into flow? Increasingly, physicists turn to quantum entanglement, that most mysterious of quantum phenomena, as the thread. Entanglement is the ghostly connection between particles, in which the state of one is inseparably linked to the state of another, even across cosmic distances. It defies locality, ignoring the separation of space, whispering of hidden unity beneath apparent division. In the holographic vision, entanglement is not merely a curiosity of particles. It may be the very scaffolding of spacetime itself. Theorists, such as Mark van Romstonk, have proposed that the geometry of space, its continuity, its ability to stretch and hold arises from patterns of quantum entanglement. To sever the entanglement between regions would be to rip apart spacetime itself, to tear the hologram at its seams. In this picture, the cosmos is not a fabric woven of matter, but of correlations. Space exists because particles are entangled. Time flows because information unfolds. The universe is a tapestry of connections, and without them, there is no stage on which reality can play. This vision invites speculation even more audacious. If entanglement and information can project a universe, then perhaps there are others, countless holograms, each projected from different codes, each with its own rules, its own constants, its own illusions of depth and solidity. In the multiverse hypothesis, every possible arrangement of physical laws might exist as its own projection, written on its own boundary. Some would be barren, some chaotic, some lifeless, and some, by chance or by necessity, might give rise to stars, planets, and conscious beings who ponder their own holographic nature. And if the hologram can flicker into being, might it also collapse? Theories of false vacuum decay suggest that our universe might not be in its lowest possible state of energy. If so, it could be precarious, a metastable illusion poised upon a false foundation. A fluctuation, perhaps triggered by quantum events, could tip the balance. The holographic code could unravel, rewriting spacetime in an instant. In such a moment, the projection would end, not with an explosion, but with a silence, reality itself erased and replaced by another alien hologram. The possibility is terrifying, that existence is fragile, conditional, resting on a balance we do not control. From here, the line between science and philosophy blurs. For if the universe is a hologram, then its likeness to a simulation is unavoidable. The idea that reality might be an artificial projection, a computation, a simulation, a dream of another intelligence arises naturally. Some, like Nick Bostrom, argue that advanced civilizations might possess the power to simulate entire universes, complete with conscious beings unaware of their status. Others argue that the holographic principle itself makes simulation unnecessary. The universe is not simulated by some machine, but is simply the natural expression of informational laws. Whether crafted or emergent, the unsettling question remains, are we real or are we shadows of code? Yet the notion of simulation may itself be too narrow. For a holographic universe does not require a simulator, does not demand an architect. It may be simply what existence is, a projection, timeless and natural, arising from laws we do not yet comprehend. To call it a simulation is to impose human metaphors upon a reality that may be stranger than imagination. The truth may not be that we live inside a computer, but that reality itself is computation, not digital in the sense of machines, but informational in its deepest essence, and so speculation multiplies. Some physicists suggest the holographic principle hints at a cosmic duality, that what we call real may always have a hidden partner. Another description, equally valid, equally true, though utterly different in form, others dream of ultimate unification, a theory where gravity, quantum fields, information, and consciousness are not separate puzzles, but facets of the same holographic jewel. In these reflections, one theme returns again and again: the idea that reality is not what it seems, that the universe, vast and ancient, may not be the ultimate stage of being, but a projection, an image, an emergent story told by codes written on unseen boundaries. It is a thought both terrifying and liberating. Terrifying because it undermines the solidity of existence. Liberating because it suggests that meaning is not confined to matter, but to information itself, a realm that endures beyond decay, beyond time, beyond the fleeting lives of stars, at the edge of science and philosophy. The holographic principle becomes not only a theory, but a mirror. It reflects back humanity's oldest questions. What is real? What is illusion? What endures when substance fades? It does not yet answer these questions. But in pointing toward a universe of shadows, it invites a deeper wonder that the shadows themselves may be the truth, and the light beyond them something we have yet to imagine. Asterisk. The greatest mysteries of the universe do not yield themselves easily. They are not written in bold letters across the sky, but whispered in faint signals, in fragile patterns, in the subtlest deviations from the expected. If the universe is holographic, if all the depth and solidity of existence is but an emergent projection, then its truth is not obvious. It must be sought with instruments of exquisite sensitivity, with machines that extend human senses far beyond their natural limits. Across observatories, laboratories, and underground chambers, science now builds the tools to test reality itself. Among the newest of these eyes is the James Webb Space Telescope. Launched into the quiet darkness of space in December 2021, suspended beyond the moon's orbit in a region of gravitational balance, it unfurled its golden mirrors like the petals of a cosmic flower. Webb is designed not to see stars as we do, but to peer into the faint infrared glow of galaxies born in the first billion years after the Big Bang. In this ancient light lie the stories of how structure emerged, how gravity sculpted the first stars, and perhaps how information itself was written into the cosmos. For if the holographic principle is true, the imprint of that encoding may ripple through the earliest radiation, a hidden grammar beneath the cosmic script. Future missions are poised to follow, focused not on starlight, but on the cosmic microwave. Background: the faint afterglow of creation. Satellites such as Light-by-RD and ground-based telescopes like the Simons Observatory and CMB's-4 will measure this radiation with unparalleled precision, seeking the faint curl of polarization, the trace of primordial gravitational waves. These signals could reveal whether space and time themselves emerged from a holographic pattern. Written at the birth of the universe, the hologram projected reality. Its first flicker might still echo in the polarization of ancient light, yet the search is not confined to the vastness of the sky. In laboratories on Earth, another frontier opens, one where quantum computers, the most delicate machines ever built, may test the very logic of holography. Unlike classical computers, which manipulate bits of information that are either 0 or 1, quantum computers weave qubits together in superpositions, entangled states that mirror the correlations suspected to underlie spacetime itself. Physicists now use these machines to simulate toy models of holographic duality, simplified universes where entanglement patterns generate emergent geometry. In their circuits, they seek to reproduce the mathematics of a DSCFT, to watch as space itself arises from entangled qubits. It is a strange endeavor to build within silicon and superconducting circuits a shadow of the cosmic hologram, to test in miniature the very principle that may govern the whole. Meanwhile, particle colliders continue to strike at the foundations of matter. At CERN's Large Hadron Collider, protons race nearly at the speed of light before colliding in bursts of energy that recreate, for the briefest moments, the conditions of the early universe. Within these collisions, physicists search not only for new particles, but for patterns, symmetries, dualities, signatures of hidden dimensions. Some theorists suggest that echoes of holography may appear in the scattering of quarks and gluons, that the geometry of spacetime could be glimpsed in the correlations of particle showers. It is not the obvious discovery of a new particle that is sought, but the subtler revelation of how the language of holography is already inscribed in quantum fields, beyond colliders. Other experiments reach for the edges of spacetime itself. Interferometers, the most sensitive rulers ever made, measure the trembling of distance at scales smaller than an atomic nucleus. They were built to catch the ripples of spacetime caused by colliding black holes, and they have. But some dream they might do more. If spacetime is holographic, then at the Planck scale, it may jitter, not smoothly continuous but granular, like pixels at the edge of perception. This holographic noise would be unimaginably faint, but interferometers tuned to its frequency could detect it. The holometer at Fermilab made the first attempt, listening for correlated noise that might betray the holographic grain of reality. Though its results were inconclusive, the idea remains alive. It's waiting for the next generation of machines. The challenge is immense. For to search for evidence of holography is to test the very stage upon which all experiments are performed. Every detector, every telescope, every computer is already inside the projection, subject to the illusion it seeks to measure. It is like a dream trying to measure its own fabric, or a painting attempting to analyze the canvas upon which it is drawn. To succeed requires not only precision but imagination, to design experiments that can glimpse the code from within the image, to hear the machinery of projection and the noise of reality itself. Still, science moves forward. Each instrument brings the boundaries closer. Webb and its successors peel back the veil of ancient light. Quantum computers sketch the outlines of emergent geometry. Colliders probe the hidden symmetries of matter. Interferometers listen to the silence between atoms, hoping to catch the whisper of holographic grain. Together, they form a great symphony of inquiry, each playing a part in a larger composition, the search to know whether the universe is fundamental or emergent, whether depth and time are real or illusions born of information. It is not one experiment alone that will answer, but the chorus of many, converging from sky and laboratory. From the language of mathematics and the logic of machines. And what then, if the evidence comes? If the polarization of ancient light reveals a holographic code, if entanglement simulations show space arising from qubits, if colliders or interferometers detect the faint signatures of projection, the answer would be both breathtaking and unsettling. For it would mean that all of existence, the galaxies, the stars, the fragile lives of conscious beings, are not ultimate but emergent. That what we call real is a shadow, projected from information we cannot touch. But even if the answer remains elusive, the search itself reshapes our vision. To build machines that test reality is to confront the deepest of human questions. What is the universe? What is real? What endures? The tools of science do not yet resolve these mysteries, but they bring us closer to the edge, to the boundary where knowledge meets wonder. In the quiet hum of superconducting circuits, the golden mirrors of telescopes unfolding in the dark, in the subterranean rings of colliders and the trembling beams of interferometers, humanity reaches for the code of the cosmos. Perhaps one day, the instruments will reveal it, the subtle deviation, the faint symmetry, the holographic whisper that tells us the universe is not what it seems. Until then, the search continues, each new tool an extension of the oldest. Impulse to look beyond the veil and to ask whether the world we inhabit is a projection or the truth behind all illusions. There are moments when science ceases to be only about equations and instruments, when it turns instead into a mirror, reflecting back the deepest questions of existence. The holographic principle is one such mirror, for beneath its mathematics lies something more profound than geometry or quantum mechanics. It carries with it a whisper, unsettling and yet luminous, that reality may not be fundamental, but emergent, projected, an image cast from information inscribed on a boundary we cannot see. If that is true, then humanity itself inhabits a fragile threshold. Every step upon the earth, every breath, every memory could be nothing more than part of a cosmic image. The solidity of mountains, the brightness of stars, the warmth of touch, all illusions born from codes, shadows of information woven into patterns beyond perception. To contemplate this is to stand at the edge of comprehension, to feel the vertigo of a world whose foundations may not be what they seem, and yet, within this fragility there is also a strange magnificence. For if all that exists is a projection, then the fact of being, the fact of experiencing joy, sorrow, wonder, is no less real. Illusion does not diminish existence, it elevates it. Just as a hologram shimmers with beauty despite being only light, the universe may shimmer with meaning despite being only information. The projection is not empty. It is filled with galaxies, with lives, with consciousness capable of asking what it means to be real. The question then arises, are we diminished or are we eternal? If matter and space are illusions, does that make us less? Or does it make us more inscribed in codes that endure beyond decay, woven into the very mathematics of existence? In a holographic universe, information is never lost. Every thought, every story, every life becomes part of the cosmic archive, etched forever upon the boundary. Mortality is transformed. What perishes in substance may endure in pattern, preserved in the language that projects reality itself. This vision casts humanity's place in a new light, no longer separate from the cosmos, drifting through indifferent stars, but part of the very code from which stars are made. To live, to think, to love, is to be woven into the holographic tapestry. In such a view, there is no division between the universe and the beings who reflect upon it. Both are projections of the same deeper truth, bound by information that transcends matter, but the fragility remains. For if the universe is a hologram, then it could change or end. The projection could flicker, collapse, dissolve into silence. Just as a holographic image vanishes when its plate is shattered, so too could reality vanish if its hidden code is rewritten. It is a thought both terrifying and humbling that the cosmos itself may not be eternal, but contingent, a fleeting shimmer of order in a sea of possibilities. And yet, even in that uncertainty, there is beauty. For existence, whether fleeting or eternal, is luminous precisely because it is fragile. The stars above, burning their fuel across millions of years, are temporary. So too are galaxies, expanding and fading into the cold. So too are lives, brief, sparks of consciousness. If all of it is a projection, then it is a projection filled with wonder, a shimmering image that knows itself, that reflects upon its own mystery. That, perhaps, is what gives the hologram meaning, that it contains within it beings capable of asking the question of what it is. Philosophy and science converge here, at the edge of understanding. If everything is a hologram, then who is the artist? Is there a hand behind the projection, a creator beyond the boundary? Or is the hologram self-existent, a natural consequence of mathematics, needing no architect at all? The question remains unanswered, suspended between belief and reason. To some, the idea invites the thought of divine design, a mind beyond the universe painting reality upon the cosmic screen. To others, it is enough that the hologram exists by itself, that the laws of physics write the code with no need for an author, but perhaps the question itself is the point. For in asking who made the projection, we reveal our deepest desire to find meaning in the illusion, to believe that our place in the hologram is not accidental, but part of a greater story. Whether that story has an author, or whether it is self-written by the mathematics of existence, remains a mystery. And it is in that mystery that wonder endures. So humanity continues to look upward into the night sky. Stars shimmer, galaxies drift, the cosmos expands. To the eye it seems infinite, real, solid, and yet beneath that illusion may lie a truth both less and more than it appears. Less, because solidity may be shadow. More, because shadow itself may be eternal. Written in information that never dies. The closing reflection is simple and yet profound. If the universe is a hologram, then every star is a projection, every galaxy a flicker of information, every life a pattern woven into the code. To live in such a cosmos is not to be less real, but to be part of something greater, a reality that transcends substance, that exists not in matter, but in meaning. And so the final question lingers, unanswerable, echoing through the corridors of science and philosophy alike. If the universe is a hologram, then who or what is the artist behind the projection?